All right, today's January 13th, 2012. Lesson 8.3, we're going to determine present value on interest that is compounded over a certain amount of time. So, the very first example, they're giving us a word problem. They want to know what the present value that Hua's parents must invest today to reach their savings goal of $20,000 by her 16th birthday. We're going to assume that she is just born, okay? So that means in 16 years. So what they're essentially asking us, we have our formula here, okay? This formula is when we're compounding interest. Most of the time when you invest in a bank account, you're going to have interest compounded over a certain amount of time, okay? The problem says they decide compound interest government bond that pays 10% per year, compounded monthly. So there's a lot of information in the first one. This bond that they're going to buy, and a bond is somewhere where you have to keep money in the bank and you can't take any money out of it until the date that it finally earns everything. So this is a 16-year bond that it looks like they're going to take. So they're going to put this in for 16 years. They need to figure out how much to invest to have $20,000 when she's 16 years old. The bond is going to get interest 10% per year or annually, but the compounding periods, compounding monthly. Okay? So there's a lot of information there. We need to decide what each of these variables is going to be. Now remember, I and n, we actually have to calculate those two. We have two formulas to calculate them to figure out what exactly they're going to be. So what I'm going to do is we're going to start with our I. So the I is equal to the interest rate they're going to get, 10%. Oh, I forgot to, oh no, I wrote that in. What is 10% as a decimal? 0.1. Good. 0.1. The compounding periods. It says it's compounding monthly, so how many times a year is this going to compound? 12 times, that's right. There's 12 months in a year. So the compounding period, our C, is going to be equal to 12. So our I is going to be 0.1 divided by 12. So we have this decimal. Bit complex. 0.0083 repeated. Now, what you can do is some of your calculators will allow you to put 1 plus, and you can actually put that fraction right into the question, okay? If you can do it all in one shot on your calculator, that's fine. If not, you can round. We're just going to round to 0.0083, okay? That's what our I is going to be. Now, our N is the number of compounding periods. Our formula for N is years multiplied by, again, the compounding period per year. So we said this is going to be around for 16 years, this bond, and it's going to compound 12 times a year. So we're calculating how many times it compounds over the life of the bond. 16 times 12. So interest will compound 192 times over 16 years. Okay? So we're going to take our formula and we're going to plug in the values that we have and we don't have. Okay? Again, this is the total amount is equal to the principal amount. That's the present value, which is essentially what we're looking for. 1 plus I to the power of n. So the total amount they want was what? 20,000. So that is our amount that we're trying to get up to. So we're going to plug 20,000 in for A. P is the principal. That's what we're trying to find. We're trying to figure out how much we should invest now to have $20,000 in 16 years. We have 1. Our I is 0.0083. And our exponent, n, is 192. That's a very large exponent. Okay? So what we can do here, quickly, is we need to isolate p. So in other words, I'm going to divide both sides of the equation by what is here. This entire bracket, including the exponent. Okay? So I'm going to show you this all in one step. We're going to divide by 1 plus 0.0083 to the power of 192. Now, you could solve for a number right there. I'm just going to show you it all in one step because in your book, they kind of rewrite it as another formula, but we really only need to remember one formula in order to do this. When we do that, we're going to end up with P is equal to 20,000 divided by 1.0083 to the power of 192. That's something you can put directly into your calculator to solve. Okay? So 1.008, and technically it's supposed to be 3 repeated, to the power of 192 for 4.92, we'll say. Chris, what's the value in the end? Say it again. You got 490. Did you put it in as a repeating decimal or as a fraction? Did you round earlier? Okay. We got 4,065. Let me just double check to make sure. 20,000 divided by 4.92. Yeah. I put mine in as a repeating decimal, so it might be a little more accurate. Okay. So either way, we'll try not to round too early when you do these questions. So what this says is if they invest right now, which is something you can know because there are bonds like this. If you were to invest $4,065 right now into a bond like this where you got 10% compounded monthly and you left it there for 16 years, in 16 years that would be $20,000. All right, so you guys have heard of the Cash for Life lottery. The way the lottery works is they give you $1,000 every week. Okay, $1,000. That says $1. That's not that much margin. So you get $1,000 a week for, now Cash for Life says for life, but I'm pretty sure the stipulation is for 25 years. It's technically like a life sentence. So you get $1,000 a week for 25 years. That's one of the stipulations in it, okay? That's a lot of money. So, now, this is a basic form of this. The way this really works is we'd actually be technically using these formulas over here, okay, which we're going to get into the second half of this chapter. We technically use these formulas to solve this, but we're going to think of it in terms of hours, and then I'll explain later why those are the two we should be using when we just get around this idea here. So, essentially what this is saying is, let's assume you don't invest this money at all. The total payout they would give you, because they're not giving you any interest, let's say you store this money in your bed and you don't earn any interest in it. If there's 52 weeks in a year, that means you guys are earning $52,000 a year over the course of 25 years. Okay. So what that means is they'll give you $1,300,000, okay, over the course of this loan. Now, let's try to make sense of this here. Let's say that there's a bank account, okay, you have a bank account where you can earn maybe 2% interest on things, okay? We want to know what the equivalent to this would be. So in other words, if you wanted a payout, let's say they said they're going to give you $520,000 right now. What? So, the lottery said they'll give you $520,000 right now. You have to figure out if this is going to be worth it to you. You have a bank account. This bank account's going to give you 2% interest, and it's going to be compounded monthly. Okay? Since this is 25 years down the road, that means you would keep the money in the bank account for 25 years. Okay? So we have to figure out if the payout they're going to give us would be worth the $1.3 million in 25 years. Okay? So in order to solve this, we're going to put this into a formula of compounding interest. Remember, we had the total amount, the principal. The principal is what they're willing to pay you right now. So we're going to see what the principal would be in order for this bank account to work. 1 plus I to the power of n. So your bank account gives you 2% compounded monthly. So that means your I, 2% as a decimal is 0.02. and we're going to be divided by 12. 0.01, repeated? Okay, 167 we're rounded to, okay? So this is the number we're working with. And again, our n is years times the compounding period. Because this is 25 years you would get this money for, and your compounding period is 12 times a year, you're looking at, is it 300? 300 times this will compound over 25 years. So we need to figure out what the present value would be worth. Is it worth more or less than this? We're trying to see if this payout they're willing to give us is essentially good for us. So we know it's going to have to equal 1.3 million. That's the total amount after 25 years. What's the principal? So if I took this amount and put it into the bank, what would get me 1.3 million in 25 years? 1 plus 0.0167 to the power of 300. Okay. This time what I'm going to do is I'm going to equate this on this side and then divide by that number. Okay, just so you guys can see it. 1.3 million is equal to P. Now this is 1.0167 power of 300. Okay, so we're going to plug this in. That number becomes 1.0167 to the power of. So 1 to the power of 300 equals 143.892. Okay, 3 million. So we're going to divide 1.3 million. Put 3 in there. Divided by 143.892. So the equivalent amount right now, right? So we just fixed that number. So 1.3 million divided by 143.8292 equals, wow. Is that right? That's a number. What does that say? 0. All right. I looked at this amount, guys. A little bit, this is unreasonable, okay? So I looked up and we left the 0 out of here. So let's fix these numbers. We left the 0 out when we went through it. Okay, so that number should have been 1.00167 to the power of 300. 1.6496. Yeah, that makes more sense. Okay, so now we have 1.64968, we'll say, okay? We divide this by that number. Divide 1.649. Okay. So what this is telling you is that in 25 years, to have $1.3 million in your bank account, you would have to invest $788,000 now. So that payout that the Cash for Life said they were going to give us is not worth it. It's too low. Okay? Because when we invest that, we won't have $1.3 million in 25 years. We would have needed an amount higher for this or equal to that to be worth it. Okay, that's what the present value of 1.3 million should have been. Okay, so to quickly make sense of this, okay, so remember they said they'd give us $520,000? Let's say we took it. In 25 years, let's see what this amount would be worth. So we would plug it in to this formula here, 1 I and n. Again, our I is going to be 0.02 divided by 12, which was 0.00167. Our compounding periods. Our years is 25 years, and it's compounded monthly, so 12 times, we get 300. So let's plug that amount in. We're going to solve for A. The present value or the principal that we put in would be that money that we took from them, 1.00167 to the power of 300. We're going to put that in the calculator in one quick shot. So 1.00167 to the power of 300. Yeah. So. Okay. So what that means is, if we taken the money they gave us as a payout and invested it in 25 years, it would have been worth $857,834. Not nearly that $1.3 million we would have got from them. So it wasn't worth it. We would have needed that 700 we said before. That 700 and what was it, 88? What did I write? Yeah, 788,000 in order for this to be worth it.